The subject of this Microcap tutorial is importing device models and the UMaine.lib library. The component wizard is not under the component window but under Windows. So go to Windows, choose Component Editor, and you will see the Component Editor window. I've created a new folder under Analog Primitives called UMaine. You can simply right-click and say Add Group, and then add the group name. Let's say I add UMaine 2. You can delete that, etc. Click on the import wizard to get what you want. So choose the file. In this case, I will go to my Dropbox folder. Alright, so in circuit libraries, I have UMaine 2015 September.lib. I will click that open. Leave these as done. Again, I'm going to leave this as default. And it will start importing the library. It will ask us, well, what is this file that I found? The model 4007 is an NMOS, so we'll choose the NMOS one. Okay. The next one is the CD4007 PMOS. Okay. And it has added all the other components. It says that 14 components were added to the demo.cmp file. 2 parts were already in the library, so it did not include them. So I will finish, and then I will save. So when I choose the file and click on any one of these devices, I should see the relevant circuit symbol, etc. So let's click on save. You'll see that I have these devices now under Analog Primitives, under UMaine. I have these devices, so for example, I can choose to bring this MOSFET here. If I double click on the MOSFET, I'll see that I have both the CD4007 and the 4007 UBE models. Likewise, if I were to import the PMOS, there's the CD4007, the 4007 UBE, and the ALD1107 models that were imported with this file. Importing these files did not require us to change any of the schematic components. We might need to do so with some other circuit elements. For example, if we go back to the import wizard and choose the TL071, this is a 5-pin circuit symbol that we will need to use, so choose the 5-pin op-amp. It has been added to the library, so under UMaine, now we have TL071. We'll save, and let's import now the 51N5231B 5.1 volt Zener diode. Again, click on Next. This time it doesn't know what it'd be looking for. Temporarily, I'll assign the Schottky symbol and finish. Now when I choose this, I should switch the symbol from Schottky to Zener. So down here there's a Zener symbol. Furthermore, the pins are on the wrong side. I know from previous experience that they are on the wrong side, so I will fix that and close it. Now if I drag F1N5231B, it treats it as if it's a IC instead of a diode. We'll let that be in this case. Let's do a quick circuit simulation to verify that we imported it correctly. Choose ground and add ground to the circuit. Let's save this as a test file, Zener test, and do a DC analysis. I will plot the device current. Since this is an equivalent circuit model for the diode, I'll do the voltage source and sweep the voltage source from 0 to 1 volts because this should be forward biased in this case. There we go. So this is pretty much characteristics of a forward biased diode. Let's throw in a 1 ohm resistor just for measurement purposes. And to test a diode, let's do a DC sweep and look at the current of R1. This does look like a forward bias diode now. If I were to instead sweep from 0 to -10 with -0.1 volt steps, we can see that the current changes. Instead, let's change R1's value to 100 and call this node Vout and plot Vout. As you can see, the output voltage is now pretty much stabilizing around 5 volts. So this is a successful Zener diode import. Just like the Zener diode was imported as an equivalent circuit, a subcircuit, the TL071 op-amp is also a subcircuit, which means that it will not actually generate power supplies automatically if you have the power supply option selected. You'll have to manually add the power supplies.